All right, moving on. The James Webb, just talked about it earlier. The James Webb Space Telescope wraps first year peering across the universe. What has it discovered? By Rebecca Sun, published 14 days ago in Space. Oppenheimer, black holes. Uh-oh. Tune in next week. I will try, the word is try, and make an attempt to talk about Oppenheimer. I have no idea how well I'm going to do, but I definitely want to talk about the actual person and a little bit of the movie. I did see the movie a couple days ago, and I really did enjoy it. But I need some time before I can put some legitimate thoughts and some research behind what I'm going to say. All right. It's been year one since we saw the first official images taken by the groundbreaking James Webb Space Telescope. Researchers have published over 750 pieces of peer-reviewed scientific literature using or citing data from the JWST. All right, groundbreaking discovery. So far, JWST has completed hundreds of research projects, including many relating to capturing the most distant observable galaxies, which, because of how long light takes to travel to us, are some of the very first galaxies in the universe. These things are pretty far away. Galaxies as distant as 13.4 million light years away, just three. I think that's wrong. No, they mean billion. JWST has managed to capture galleons as distant as 13.4 billion light years away, just 320 million years after the Big Bang, or when they believe the Big Bang happened. Some of these galaxies have surprising qualities, such as unexpectedly large size or higher rates of star formation than expected. Another area JWST has made strides in its exoplanet research, including taking detailed measurements of the atmosphere of exoplanets, something I've talked about on this podcast. For instance, those in the TRAPPIST-1 system, a group of 7 exoplanets about 40 light years away, orbiting a small star. The distance is the largest known collection of Earth-sized exoplanet in a star's habitable zone, which we've talked about before. In research, researchers were able to use infrared radiation data from a secondary eclipse or when a planet passes behind TRAPPIST-1 to learn that TRAPPIST-1b, the innermost planet, does not have an atmosphere. Closer to home, Webb has made some surprising discoveries in our asteroid belt. JWST was used to identify the first known comet surrounded by water vapor in the asteroid belt. Previously, comets containing water ice had only been found in the faraway Oort cloud in the Kuiper belt. Water vapor in the asteroid belt is huge. That means there's some kind of mechanism preserving water ice on an asteroid-like body that close to our sun. And then here's an actual image. Very cool of that thing. That's really cool. Nice. All right. Exceeding expectations from the start. If you remember those first images by JWST, it was insane. The Orion Nebula. 3 views of planet-forming disk in the Orion Nebula taken with the JWST. I mean, this is just the images that you could take if you go look on, just search up James Webb Space Telescope, go to the NASA website or whoever you want to watch, and just look at the images that it's put out from the beginning. It's really beautiful. What's next? In the next year, researchers will build on what they've learned this year using JWST and doing more and more missions. And this is a story on NASA's Webb Telescope discovering the most distant supermassive black hole ever. So we are not done with the discoveries. This is July 10th, 2023. NASA's James Webb Space Telescope has been sending back a lot of cool stuff. include the supermassive black hole CEERS 1019. The black hole is not only the most distant on record, but it is also less massive than any other black hole identified in the early universe. Not only that, but JWST also detected 2 more black holes in 11 galaxies that existed when the universe was only 670 to or 470 to 675 million years old. The images that were collected by JWST and stitched together in a panoramic view are part of Webb's Cosmic Evolution Early Release Science Survey. That's what CEERS is. The unique program takes Webb's extremely detailed near and mid-infrared images and data known as spectra. All right. You can kind of see the Sears age of the year. Sears 1019. Yeah, so that's the one right there. It's under 600 million years black hole mass. It's a very small one. See, 10 million? 10 million solar masses. That's not crazy. It's not massive or anything. I'm not being facetious. I'm being in terms of black holes, it's not super crazy large. Yeah. Weighs in at about 9 million solar masses, far less than any other black hole in the early universe. In comparison, the other black holes typically come at more than 1 billion times the mass of the sun. Yeah, fairly small compared to the other ones. Research said that it existed so much earlier that it's more difficult to explain how it formed so soon following the beginning of the universe. They also said that the supermassive black hole may not be the record holder for the most distant for long, as there are other black holes that have been identified by JWST that are currently being reviewed by the astronomical community. So, quick point. This is, as we know of right now, a very young black hole. And the thing is, they're saying that this is maybe a couple hundred million years after the universe formed, when they believe that the universe is about almost 14 billion years old, and this is only a couple hundred million. So in the grand scheme of things, it's not a huge percentage of how far of a journey it's gotten through our particular universe. But with the James Webb, they're starting to see, they're able to look further and further and further out. They're able to see things that are possibly up to 15 billion years ago. And they haven't done it yet, but I think that that might be on the horizon. If not with the JWST, maybe with a more powerful telescope, we'll be able to look out further and further and further. Who knows how big this universe is? Who knows how old it is? I think there is very strong evidence for a Big Bang and for a massive explosion in the beginning, and maybe we're part of a multiverse where there's multiple universes and we're just a little tiny speck on that just kind of started. But we're part of a whole giant group of different galaxies. I don't know. I mean, that'd be pretty cool to think of, but I do not know. There aren't no right answers. All right, looking at this distant object with this telescope is a lot like looking at data from black holes that exist in galaxies near our own. There are so many spectral lines to analyze. We're not used to seeing so much structure in images at these distances. A galaxy merger could be partially responsible for fueling the activity in this galaxy's black hole, and that could also lead to increased star formation. I am overwhelmed by the amount of highly detailed spectra of remote galaxies. Webb returned. Cool ass data. All right, so more James Webb Space Telescope stuff. This is space.com. James Webb Space Telescope gets satellite sidekick to aid search for habitable planets. I do think that in the upcoming years, they will have really good evidence that there's life out here. I can only hope. Um, although they are doing some hearings in Congress, or they're doing something with UFOs today. They already did do them. Are there really aliens and are there actual crafts on our planet right now, as we speak, that the highest levels of government is aware of and in possession of? I'd really like to think so. Um, and it's okay if they want to hide that from us. I don't really have an issue with it. I am more concerned with the fact that there is life, intelligent life, especially life that is more intelligent than we are, that is on our planet, is something that is interesting to me. Right, the two spacecraft are complementary. JWST scrutinizes the atmosphere of rocky planets that may be host to life, such as its recent examination of exoplanet in the TRAPPIST-1 system. We talked about that. And then this other satellite, Mantis, will look at star activity such as flares after its launch in 2026. The Mantis spacecraft will look at the sky in ultraviolet light, including the most energetic set of wavelength known as extreme ultraviolet. It will be the first to examine the sky in that range since NASA Extreme Ultraviolet Explorer that retired in 2001. Here's the theory. Rocky exoplanets with water on their surface may face extra challenges if they orbit a very active star, given the amount of radiation such planets will be exposed to. Mantis aims to provide more data to refine that theory across a year of observations from Earth orbit. So, if there's a lot of radiation, there's going to be a lot of mother truckers that are going to be sunburnt. So, over millions and millions of years, if not billions of years, what does that do to a planet? Is there an atmosphere that's able to even form? If there's that much UV radiation, is there life that's able to stay protected and not get burned to a crisp? Mantis will carry two telescopes into space, one optimized for lower energy UV radiation and a never before seen flown telescope type looking at the extreme UV range. For a lot of stars, this is going to be like the first time we've seen what they look like in extreme UV. All right, so the Mantis, this other telescope, is adapting from technology on two other university CubeSats, an exoplanet mission called the Colorado Ultraviolet Transit Experiment that launched in 2021, and the supernova remnants and proxies for reionization testbed experiment that is scheduled to seek the leftovers of star explosions in 2024. Once ready for science, observing Mantis aims to help scientists learn how stellar energy affects the atmospheres of planets in the vicinity, especially for those planets that are close to Earth's size and may be habitable. So the combination of these two could help us better understand even exoplanets that we have already seen, but get a better understanding of, is there too much radiation around these planets, specifically using this Mantis telescope and using the combination of these two could potentially really make a large difference in what we're talking about. Once again, this is Mantis and the James Webb coming together to help us figure stuff out. Another story about the Webb telescope. This is a article on NASA. Speaking on well, let's read it. You can kind of see stars. Boom. 13 billion years ago to now. In the early universe, the gas between stars and galaxies was opaque. Energetic starlight could not penetrate it. But 1 billion years after the Big Bang, the gas had become completely transparent. Why? New data from NASA's James Webb Space Telescope has pinpointed the reason. The galaxy's stars emitted enough light to heat and ionize the gas around them, clearing our collective view over hundreds of millions of years. The results from a research team led by Simon Lilly of ETH Zurich and Switzerland are the newest insights about a time period known as the era of reionization, when the universe underwent dramatic changes. After the Big Bang, the universe was incredibly hot and dense. Over hundreds of millions of years, the gas cooled. Then the universe hit repeat. The gas again became hot and ionized, likely due to the formation of early stars and galaxies, and then over millions of years became transparent. Researchers have long sought definitive evidence to explain these transformations. The new results effectively pull back the curtain at the end of this reionization period. Not only does Webb clearly show that these transparent regions are found around galaxies, we've also measured how large they are, explained Daichi Kishino of Nagoya University in Japan. With Webb's data, we are seeing galaxies reionize the gas around them. These regions of transparent gas are gigantic compared to the galaxies. Imagine a hot air balloon with a pea suspended inside. Webb's data shows that these relatively tiny galaxies drove reionization, clearing massive regions of space around them. For the next 100 million years, these transparent bubbles continue to go larger and larger, eventually merging and causing the entire universe to become transparent. You can kind of go back to this image here and kind of see. Now imagine the center of these is a pea, and the outside of it is a hot air balloon. I mean, that's a pea. What kind of pea? Like a snap pea? Those are pretty good. Have it with a little bit of olive oil and a little bit of salt. That's pretty much all you need. Just like if you were to take a piece of sourdough bread, throw it with some butter on it. Butter doesn't even have to be melted. Butter doesn't have to be super soft or anything. Put some butter on it. Throw it in a toaster if you have one, or a microwave oven or whatever. And then toast it. Take it out. Put some garlic powder and some salt on it. Eat that. Oh, that sounds good. Anyways, later in the show, we will talk about food, I promise. But if you want a good snack and a good source of carbs and fat, that's where you want to go. As the quasar's lights traveled towards us through different patches of gas, it was either absorbed by gas that was opaque or moved freely through transparent gas. The team's groundbreaking results were only possible by pairing Webb's data with observations of the central quasar for the WM Keck Observatory in Hawaii and the European Southern Observatory's Very Large Telescope and the Magellan Telescope at Los Campanas Observatory, both in Chile. The researchers then used Webb to identify galaxies near this line of sight and showed that these galaxies are generally surrounded by transparent regions about 2 million light years in radius. In other words, Webb witnessed galaxies in the process of clearing the space around them at the end of the era of reionization. To put this in perspective, the area these galaxies have cleared is approximately the same distance as the space between our Milky Way galaxy and our nearest galaxy neighbor Andromeda. Until now, researchers didn't have this definitive evidence of what caused reionization before Webb. What do these galaxies look like? The more chaotic than those in the nearby universe. Webb shows they are actively forming stars and must have been shooting off many supernovae. They had quite an adventurous youth. You can kind of see them here, kind of all over the place. When the universe was only 900 million years old, never before seen structures. These distant galaxies are clumpy, often elongated, and are actively forming stars. These are very young suckers. Along the way, Webb's data was used to confirm that the black hole and the quasar at the center of this field is the most massive currently known in the early universe, weighing 10 billion times the mass of the sun. We still can't explain how quasars were able to grow so large so early in the history of the universe. Maybe it's not that close to the beginning of the universe. maybe this thing's a little bit older. The team will soon dive into research about galaxies in 5 additional fields, each anchored by a natural quasar. Webb's results from the first field were so overwhelming and clear that they couldn't wait to share them. We expected to identify a few dozen galaxies that existed during the era of reionization, but we're able to pick out 117. All right. Then it kind of continues to go onwards.